Hi, welcome to lesson number 3, module 5 of the Apache Spark and Scala course. So in this particular lesson, we will be concentrating on the data frame API and the SQL context object to get an in-depth understanding of how these two components play a major role in Spark SQL. So before we proceed with the lesson, let's quickly recap the last lesson. In the last lesson, we basically learned about the Spark SQL library, its architecture, and how it fits in the entire Spark ecosystem. So in this lesson, we will be talking about the different components of Spark SQL, the data frame API in special, and a comparison of a data frame and an RDD, and the SQL context. So if you want to work with Spark SQL, then obviously one thing that you have to know is the SQL language. And I am assuming that all of us are familiar with SQL or the Hive query language, and that is how you analyze the data. Apart from the knowledge of the language, you need to understand the data frame API and the SQL context object. So these are the two main components. So first, let's see what is a data frame API. Now, a data frame is very similar to an RDD. Now, basically, a data frame is an abstraction over your data. And you can think about a data frame as a very similar to a table in an RDBMS, which is made up of rows and having named columns. In the context of a data frame, we have something called row object and then named columns. Now, the concept of data frame is actually inspired from Python's Panda package and the R. And you can see from the picture that the data frame is nothing but an RDD with certain schema. So normally when you create an RDD, there is no schema associated with the RDD, right? But if you can associate a schema with an RDD and project a table-like structure to that, then you have got your data frame. That's it. So that is the basic difference between data frame and your core RDD. So here we can see a look at the features of data frame, and as you are aware, it is a distributed collection of data, basically like a table structure, and there is Hive compatibility. You can run queries on the data stored in Hive. You can process structured and semi-structured data, and it has a built-in Catalyst optimizer. That's something to boast of, because the point here is that when you are having core RDDs and if you write a Spark program, then there is no built-in optimization, but Spark SQL actually has a built-in optimizer, and you can natively program the data frame API using Java, Scala, Python, and R. So here you can see that all the 4 languages are supported in the data frame. Now, the one thing that you have to understand is the different ways to create a data frame in Spark. So unless you have a data frame, you cannot query the data, right? So the first question will be that, well, how do I create a data frame? So the first way is that you can actually create it from a Hive table. So Spark SQL can natively access Hive's metastore. And you can create a data frame from Hive's data. You can also create it from a CSV data or a JSON data. And Spark SQL even allows you to connect with an RDBMS table using the JDBC connection string and create a data frame from the data which is stored in RDBMS. Even you can create it from XML and Parquet and NoSQL such as Cassandra. And very interestingly, if you are already having an RDD, and if that RDD is holding some data, you can create a data frame from the RDD as well. So here is a quick comparison between your data frame and the RDD. Now, the major difference here is that in the data frame, the optimized transformation is shipped on the cluster. So since there is a very powerful Catalyst optimizer, even though you write a very normal SQL on your data frame, the code will be compiled and optimized, and the final optimized code is shipped in the cluster. But in RDDs, the actual transformation is shipped. The optimization might or might not take place later. And in the data frame, the schema is mandatory since we are having a table-like structure. Either you can ask Spark SQL to infer the schema automatically, or you can manually specify the schema. But for RDD, there is nothing like a schema. And data frame has a SQL parser and optimizer. RDDs doesn't have any parsers or optimizers. And data frame API is built on SQL, which is again built on RDD. And RDDs are the lowest API on platform. So this is a very important point. The lowest level of API is actually an RDD, meaning the Spark core actually understands only the RDD API. And when you are creating a data frame, that is again another API that is built on SQL, which is again built on RDD. So there are two levels of access in here. And data frame, if you are creating the RDD using Scala or Python, it will have the same performance since the optimizer remains the same. But RDDs, based on the language, the performance might vary. So here you can see a graph which basically shows you a very interesting example. So the example that we are taking here is that we are creating, or we are trying to aggregate 10 million integer pairs, and we are doing it using core Spark and Spark SQL. And when you look at the graph, you can see that if you are writing your core Spark in Scala, it takes somewhere around 4 seconds to do this. But the same core Spark code in Python takes more time to execute. So somewhere around 9 seconds, I can say. But the data frames, whether it is in SQL or Python or Scala, are fast, and they take the same time, almost about 2 seconds. Here is another example of discussing how somebody should really use the concept of data frame. So let's say we are having a structured data file. Let's say we have a text file, and let's say we want to do some transformation and then collect the data. So if I want to write a Spark code, then I have to first read the data into an RDD. So here I'm creating an RDD called data, and I'm using the sc.textFile method. Then I'm splitting it using tab. And then this is a Python code that I'm using. I'm doing a data.map where I'm using my Lambda functionality. I'm just accessing the first element. Then I'm accessing the second element and converting it into 1. And then I'm using the reduce by key method, again a map on Lambda, and then collect. So basically you can see that even though we are using Spark code, we are using multiple transformations and it is pretty much complex. But the same thing in Spark SQL will be a simple SQL context.table people, which means I want to create a table called people, and I just want to group by name, find the average of name, and I want to aggregate by name and the average of age, and then just collect. So you see the simplicity of code, and that is one reason people go for Spark SQL. Now the next thing that you have to understand is the SQL context. Now the SQL context is the entry point to your Spark SQL library. It is an object and that is used to access and initialize Spark SQL functionality. Now, if you are working on the REPL, then the SQL context object is by default available to you. However, if you are writing a program, then you have to create a new SQL context object, like you can see on my screen. So here you can say val SQL context equals to new org Apache Spark SQL context in brackets SC. So an interesting point here is that the SQL context object in turn refers to the Spark context object for accessing the functionality. So you're having two layers here. The top layer is the SQL context object, which in turn connects to your Spark context object, and then you access the core Spark functionality. So to wrap up, we have learned about the components of Spark SQL, specifically the data frame API, its features, a comparison between data frame and RDD, why data frame, and what exactly is the SQL context object. And that's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.